Okay, so I'm going to do question number 15 from the homework, which is very similar to a question that we did in class. So we have a 15-meter high cliff. We have an object that's launched off the cliff at an angle of 35 degrees and a speed of 55 meters per second is v0. And we want to know, first of all, how long is it in the air? So we want to know, goes down like this. We want to know how long does it take to go across for part A. Part B asks how far does it travel in the meantime. Part C, D, and E ask about its speed when it hits the ground. And part F asks how high does it go above the top of the cliff. So most of those questions we answered in a question in class where we had a diver jumping off a diving board into a swimming pool. But let's do it again. All right, so first things first, when we do a problem like this, break the velocity into components in the x direction and the y direction. So let's do this. So v0 is 55. This angle's 35. So v0x is adjacent, so it's cosine, so it's going to be 55 cosine 35. It's 45.05 meters per second. And you'll notice I'm keeping a bunch more sig figs than in the problem. All right, v0y is then going to be sine, so it's going to be 55 sine 35, which is 31.55 meters per second. All right, so look back at the rules that we had for doing projectile motion problems, and remember we said for the time there were two ways to solve it, and the only way to solve it if it landed at a different height to where it took off was to use the quadratic formula. So where does it take off from? It takes off from the top of the cliff, so y0 is 15 meters. Where does it land? It lands down on the ground, so y final is 0 meters. So we're going to use the equation y final equals y initial plus v0 yt minus 1/2 gt squared. So always remember your recipe. You can do exactly the same things. Now plug in our numbers. So y final was 0, y initial was 15, v0y up here is 31.55 times t minus 1/2 of g, 1/2 of 9.8, which is 4.9 t squared. All right, so this is the quadratic equation. That term's c, that term's b, and minus 4.9 is a. So t is equal to negative b, so minus 31.55, plus or minus the square root of b squared, so 31.55 squared, minus 4 times a, which is minus 4.9, times c, which is 15. And that's all divided by 2 times a, which is minus 4.9. Right, so throw that in your calculator. This is where you're more likely to go wrong. What I always do is I calculate the last term in there first, then I add on the first term, and then I take the square root, and then I do the thing in front. So I always calculate the thing in the square root first. So if I do this, I get 2 times. I get negative 0.44 seconds and plus 6.88 seconds. All right, so I got to take the positive time. So the answer for part A is 6.88 seconds. All right, part B, how far does it travel? So we had 2 rules. How far it travels horizontally is we can use the range equation if it lands at the same height. Otherwise, we have to use that the distance it travels is v0x times t. And we know those. v0x is 45.05 meters per second. And we just found t, 6.88 seconds. And so if I plug all that in, I get a distance of 309.94 meters, and I should round that to 310. and the time I should round to 7.0 seconds. But when I plug these times, the time in here, I'm going to keep all my sig figs. All right, C, D, and E ask about the speed at the bottom. Okay, so Vx, we know since there's no friction, the speed in the x direction is always the same. So the speed when it hits the ground in the x direction is just going to be what it started with, 45.05 meters per second. What happens in the y direction? Well, in the y direction, it starts going up with a speed of 31.55, slows down, slows down, slows down. When it's at its highest point, Vy equals 0, and then it starts to accelerate going down. And the equation we have for Vy is Vy equals Vy initial minus g times t. So Vy initial, 31.55, g is 9.8, and t we found is 6.88 seconds. So Vy is equal to minus 35.87 meters per second, and that minus just means it's going down. All right, so that's the answer for part C. Part D asks, what's the magnitude? All right, so now we know that we're going 45 across, and we're going 35.87 down, and we want to find the hypotenuse. So we just use Pythagoras. So V is the square root of Vx squared plus Vy squared. And you plug in all your numbers, and we get 57.59 meters per second. And again, we should round these numbers off. So that should be 58 meters per second. Okay, part E asks, what's the angle? So I want to know what's that angle in there. And remember, at the beginning of chapter 3, tan theta is Vy over Vx. So it's going to be minus 35.87 over 45.05. So I get negative 0.796. So theta is going to be inverse tan of minus 0.796. And so I get minus 38.5 degrees. Okay, so I've done A, B, C, D, E. Last part is F. What's the maximum height that it reaches? All right, so and it asks what's the maximum height above the top of the cliff. So it says that means take your initial height with respect to there. All right, so how do we do that? Well, we know that at the very top, Vy is equal to 0 where it's turning around. And we know it started off with Vy initial of 31.55. So what do we use? We use this equation, Vy squared equals Vy initial squared minus 2g times y minus y initial, which is just our height. Okay, so Vy, 0 squared, minus 31.55 squared, minus 2 times 9.8 times h. And if I rearrange that, I get h is equal to 0 squared minus 31.55 squared divided by 2 minus 2 times 9.8. Remember, you got to do it in the right order so you get a positive height. And if I do that, I get a height of 50.8 meters. And I guess since I wrote down my numbers with 2 sig figs, I should round that up to 51 meters. Okay, so there is a quick walkthrough. Again, we did A and B and F in class, and C, D, and E is just basically vector math on the velocity at the bottom. Hope that helped.